I'm going to start recording now. Hey guys, it's Param from DataStack Academy. Today I'm going to talk about cloud functions. Cloud functions have been a great tool both in web app development, and now they're making their way into data engineering, and we want to talk about how to use them for data engineering specifically today. So what are cloud functions and what are the benefits? Cloud functions, just like their name, there are code or functions, just pure code that are deployed to the cloud. And they're super easy because you can take any script, any code, any function that you have and easily deploy them and run them on the cloud. And they can be written in a number of different languages. For right now, like Google, supports Python, .NET, Java, Node.js, Go, PHP, Perl, and that number is growing. The main benefit of function is that they're serverless. So they don't require any dedicated servers to run. You only get charged by the milliseconds of how long your function executes. A lot of the cloud vendors, or actually all the cloud vendors, also have a free tier. So with decent amount of execution, actually, you won't even be charged, and they scale automatically. So the cloud automatically scales more functions for you as you need more execution or things to process. The thing that makes them nice in data engineering is that cloud functions can be triggered by events. So they can reply or they can respond to live events or live data in real time. And there's a number of different events that can trigger cloud functions. For example, HTTP triggers. So that's when a cloud function, it just acts as a REST API. So when you do HTTP post or get, the cloud function gets invoked and runs. But also you have these cloud events that can initiate a cloud function to execute, like storage operations. So that's when like a file gets uploaded to the cloud storage, and that triggers your cloud function to run. And that's a great way to trigger processing for that file immediately. There's also, they can be triggered by pub subs, so live streaming of data, and those are like game logs, application logs are very common in that category, or even Firestore or Firebase events. So when a Firebase or Firestore document, a JSON document, gets updated, that triggers your cloud function, and you can actually ingest that data. That's very handy to interact directly with like web applications. They could also be triggered by schedules, so by time triggers. And that's there's a tool on Google or GCP called Google Workflows that enables this. You can see that everything I talk about right now is Google, and our demo is on Google Cloud or GCP, but cloud functions, all of these features that I'm talking about, they exist in all the other clouds. So on Azure, they're just called Azure functions. On AWS, they're called AWS Lambda functions. And all of these functions are still, the same. They're also ideal for processing small number or small volumes of data volumes per cloud function, because cloud functions are not really designed to long for a very long time, or they don't really take a lot of compute or memory resources. They are very good for processing small real-time data volumes, and that's typically in megabytes, like max a gigabyte or 10 gigabytes range. They're very good for processing structured, semi-structured, and even unstructured data sources. So let me give you an example where cloud functions have been used for a long time in web development, and especially in a design that's called microservice design. So take like Amazon. A lot of the sections of a web page, the data from them is refreshed by connecting to a REST API. And since cloud functions can be invoked as REST API or HTTP requests, they can act as these microservices. So each section of like a page like Amazon connects to a cloud function on the back end to grab the data from the server. For example, you can see my Amazon, like the previous searches have done, like that box. There is a cloud function for that. There is a cloud function for stuff that I've bought in previously, a cloud function for the current deals that are running on Amazon, also a cloud function for like my shopping cart. And you can see how you can easily kind of build piecemeal together the different pieces of this application by these microservices or small functions that can be um, uh, developed kind of simultaneously or in silos, and you can piecemeal them together. Now, what does that look like in data engineering, and what are the ways that we can use cloud functions more for data? And I told you that the cloud functions can be triggered, and that's really the main event here. Because they can be triggered based on events, you can have them respond to live data events that happens on the cloud. One of those events could be, like, for example, processing files. So when a file gets uploaded to a cloud storage, like Google Cloud Storage, that triggers a cloud function. And then you can use that cloud function to ingest that file into your data lake or your BigQuery. Another type could be ingesting data from applications directly. So again, when applications write their logs to PubSub or maybe interact with Firestore to change user data, to change shopping carts, etc., those can trigger events. So those can trigger your cloud function to run, and you can use the cloud function to ingest that data again into your data lake, or in this case, maybe something like Bigtable. Another example would be when you use cloud functions more to fetch data, so not really in more as a trigger element, but to go and fetch things. In this case, you need some other component to actually run your cloud function, and that component is some sort of scheduler on the cloud. A lot of cloud have these very light schedulers that are serverless as well. In case of Google, that's Google Workflow, and that can trigger your cloud function, and now your cloud function can go fetch data, for example, from a database. This could be like in case of Google, like SQL Spanner, and then ingest that into the data lake. Another one to be just directly applications. Again, cloud function can be triggered by HTTP triggers. So that's when an application can just post data to your cloud function, and you can ingest that into your data lake. For more complex examples of data lake, again, you need some sort of orchestrator or scheduler. Google Workflow is very good for this because it can sequence multiple functions to write sequentially or in parallel. And that feature is also, again, available on AWS and Azure as well. They're just called differently on those services. And that's when you want to have multiple functions that individually do different things, and then you can sequence them together to create a more complex workflow, as you see here. Let me just give you an example, again, how you can use cloud functions in a complex sort of ingestion pipeline. So in this case, like if you have an audio or video file that gets loaded to your cloud storage, that can trigger a number of different cloud functions, or it can trigger, again, a workflow pipeline that then you can sequence these cloud functions together. And what's nice here is that you design cloud functions, again, in a microservice manner where each function serves a different purpose in your data pipeline, and they can be managed and developed individually. So in this case, like, you can have a function that just that does like computer vision and detect objects on your video or in your speech, maybe detects like the people who are speaking. You have another function that does speech to text, and that triggers like an NLP, like sentiment analysis function. And then you have just a basic function that just archives that video file on your cloud storage. And all of these can write into BigQuery their output, and then you can use the BigQuery to further analyze the data. So let me give you guys a demo here. So what I'm going to do, I'm going to show you how to build and deploy a simple HTTP trigger function, and you can see how easy it is to deploy cloud functions to the cloud and write them. And then I'm going to show you a storage trigger function. So this is when I'm going to put something on the Google storage, and that automatically initiates the processing for that file to happen on Google. So I'm going to switch here to my VS Code. You guys should be pretty familiar with VS Code. And I've prepared a Git project here, which I will share with you guys at the end of this demo, so you can code along with everything that I'm doing here. And in this Git repo, or in this Git project, you have a README, which if you follow it, it has all the instructions kind of line by line to build and deploy your cloud function here. And in here, so the first thing that you would do to deploy a cloud function, you can just create any directory into a cloud function. And all you need for, in case of Python, is a main.py and a requirements txt. In the requirement txt, just like how you use Python code, you can put all your PyPy or pip install packages that you want to include with your cloud function, and you can use them then in your function. In this case, we use a how do I and a Flask, the Python Flask, which everybody's familiar with, and the how do I package. How do I package is a really cool package that you can use coding questions, and it searches like Stack Overflow and tons of other sites, and actually responds to you with a coding question. So I'm going to create a main, and here you can just define any function. So we're going to call this like simple function. So you create a simple Python function, and you can turn that into a cloud function to run on cloud. And we'll show you this in a few seconds. So my function in this case, because this is HTTP request, it accepts a Flask request object. And in here, I'm going to accept a name from the request parameters. So if my request args, my get URL parameters had something called, like, let's say name, I'm going to get that, and default is going to be like anonymous. And I'm just going to return that. So return hello, and return this as an f-string function. Hello name, just return something back, and return the HTTP status 200. So very simple, just like a Flask app. You have a request object, which in this case, in the case of HTTP cloud function, we can get the HTTP request that was sent to us. We can get the data for that, the URL parameters, and we can do any processing inside our function, and then we can just return a basic response back, just like in case of Flask. So this is our response, which is just a text response, and it is our HTTP response code. So I'm going to save this, and in this case, you can pip install a package called Functions Framework from Google Cloud, and that allows me to test this function locally before I deploy it to the cloud. So I'm going to say Functions Framework. Let me deactivate and activate my virtual environment again. It's not tab completing. There you go, better. So Functions Framework takes a couple arguments. The target is actually the name of the function that you want to run in your main.py, so simple function, and we have a port, which we say to run this function on port 880. Oh, I have to actually go to my Cloud Functions directory, because that's where my main.py exists. All right, and that function, you see how simple it is, and that function is running on my local machine. And I can use Postman now to interact with this function. So let's just do the simple. So I'm going to send my name, and you see localhost port 880, and I'm going to send a name argument with my name. And why did I not get a response? Oh, that's why it should have warned me that my name argument should be in quotes. I can't use that before I use it. So go back. All right, there we go. It runs. And I'm going to show you guys how to deploy this, how easily to deploy this to the cloud as well. But before we do that, we're going to make a little harder function, which is our how do I example. So I'm going to come and copy and paste some code from here, which I've written before, and I'll explain to you guys what this code is doing. So I'll copy and paste my previous example. I still have my simple function, but in this case, I added another function, which is my how do I function, which I get to ask how do I library a coding question. In this case, I still get a request. The question comes from a URL parameter called question, which I get the question that I have. I'm going to check if that question is none. If it's none, my answer is like, hey, you forgot to give me a question. And if otherwise, I'm going to ask the how do I library that question, get my response in terms of answer. I'm going to construct my HTTP headers. I'm going to say my content type for my response is text, and my server time, which is now as a header, and respond back with the answer, the HTTP response code, and my headers. So this should be pretty straightforward. And to deploy this function to the cloud, I can use the Google Cloud, the G Cloud command line. I'm going to say G Cloud functions deploy while I'm inside my directory, and very easy. So again, my entry point is the name of function that I want to run or deploy. So it's how do I function. My runtime is the argument which Python version I'd like to use. So in this case, I'm using Python 3.7. We're going to say how this function is triggered, and that's an HTTP triggered function. So triggered by HTTP. And in this case, I don't have any security, so I'm going to allow on an authenticated HTTP request, but I can also secure my function by having a key as well. So, and I'm missing an argument here. Allow bigger running time. Oh, I forgot my function name. So my first argument actually would be the Google function that I want to deploy. So in this case, I'm going to say DataStack Academy, how do I, and this function should be unique within your project on the Google Cloud. Okay. And it's very simple and quick. It takes about a couple minutes. It packs up your directory, and it is uploading that to the cloud, and we can actually, and it will get a URL where we can invoke our function at the end on the cloud. While this deploys, I'm going to explain a couple other things. You can also use your own packages in your functions. So in this case, you have, we have a utils package, so you can have your own libraries and you can use them just as you import any other local package here inside your code, and it should be very simple again, and Google just deploys those to the cloud. For anything inside the directory that you don't want to be deployed to the cloud, you can also include a cloud ignore. So in this case, I'm ignoring a lot of my Python build classes. You can put those in your gcloud ignore file, and those get ignored when they're being launched on the cloud. So in this case, I am going to, I've already actually deployed this to my cloud. So I'm going to go and use this one. So how do I example on the cloud? So again, now you see that I'm using the Google Cloud URL. This is my function that is deployed on the cloud. And I'm going to ask it a question. How do I loop through lists in Python, for example? Let's send this to the cloud, and that should invoke our function. If one in numbers, that's not quite right, but how do I, for example, convert a string into int? And you see that answer, the coding answer. And if I come back here and you see my function, in this case, it wasn't deployed for some reason. Well, I'll have to go look at that, but that's very strange. They always deploy very easily. All right. So I'm going to continue with the presentation. Also, what I'd like to point out here, the Git repo that I will send out after today is going to have this other function, which is storage trigger function, and it's going to have a README to deploy this storage trigger function. In this case, you're going to write a function that processes a data file as soon as it is uploaded to the cloud. So feel free to take a look at that. Coming up to our time, so I want to just wrap up by first, thanks everybody for joining to our webinar and live stream today. And I wanted to also point you guys to DataStack Academy. So this presentation is part of the DataStack Academy webinar series. I'm Param, the founder of DataStack Academy. And DataStack, we have a great data engineering bootcamp. We have a cohort starting actually in August. You can go and get all the information on DataStack Academy .academy or datastackacademy.com. There's a lot of useful links there. You can actually click a button to get started for free, which will get you the first 2 chapters of our data engineering bootcamp. You can test that, see how you like it. You can also schedule a one-on-one call with me. I always love talking to you. If you're interested in data engineering, I'd be more than happy to listen and answer any questions for you. Thanks again for joining in today. Hopefully today's webinar gave you guys some information about cloud functions and how you use them. Go on datastack.academy and look for our upcoming webinars. Thanks, guys. I'm going to stay on chat for a little while to see if there's any questions, and then I will stop the live stream.